6.3, first video. Just a couple properties I want to look at before we get started. We are going to continue on with radicals, roots, and those are kind of like my favorite. So anyway, I have fun with them. So if we have a radical such as the cubed root of 4x, that is the same as the cubed root of 4 times the cubed root of x. So basically all that means is we're putting this cubed root on each of the pieces of this that are multiplied together. The same happens with division, property 2 for radicals. They're using letters in there, but I prefer to use actual numbers. So if we've got the square root of 9/25, that's the same as the square root of 9 over the square root of 25, which equals 3/5. So I'm looking at a simplified form for radical expressions. This is middle of page 515. It just gives you some rules, and I just put this one down here as an example to kind of go along with the rule. It says a radical expression is simplified, which means it can't be reduced anymore. You can't do anything else to it. If none of the factors of the radicand, this is the radicand, none of the factors of the radicand can be written as powers greater than or equal to the index. That is, no perfect squares can be factors of the quantity under a square root sign. Okay, so basically that means that this cannot be reduced anymore. Let's say, for instance, this y had a 6 on it. What that means is there's an index here of 2. This, it's an assumed 2 here, the square root of. If this number, the 2, is smaller than one of the exponents in here, it's not reduced as far as it can go, because we have a 6 here and this is a 2. Whereas before, when I had nothing on there, basically a 1, that 1 is less than the 2 that's over here, so that's okay. This 3 also has a 1. It can't be reduced. It can't be made smaller. So that's the first point. There are no fractions under the radical sign, which is the case here. There's no fractions. And there are no radicals in the denominator. You can never, ever in the history of the world have, remember I had 3, if I had the fraction there, that means the square root of 5 over the square root of 7. You can never have a radical in the denominator. It's not that it's wrong, it's just that it's not reduced or simplified. So you cannot have a radical left in the denominator in your answer. So that means this is not simplified all the way. Okay, there isn't one here, so we're good to go. All right, so let's just start looking at putting some of this information into practice, because that's really all we're doing with this is we're reducing or we're simplifying. So they start out with the square root of 50. Now, the way I suggest doing this is when you have the square root of just a number, try to find out, if we want to simplify it, try to find out if there's two numbers multiplied together that give you 50, that you can take the square root of one of them. That's usually my first bit of advice. So this is the square root of 25 times 2. Okay, it's also the square root of 10 times 2. But I can't take the square root of 10 or the square root of 2, so I don't want to use that. But because I can take the square root of 25, I want to use that one. It just makes it easier. You can use anything you want, but this just makes it easier. So that is equal to the square root of 25 and the square root of 2. Square root of 25 is 5. Cannot take the square root of 2, so you leave it in the radical sign, and you're done. Okay, so that's pretty much what that looks like when you have just a number in that radical sign. So for instance, if I had square root of 18. Sure, I've got the square root of 6 times the square root of 3 gives me the square root of 18, but the square root of 9 times the square root of 2 works better because I can take the square root of 9 and get 3, so the radical sign disappears. Can't do anything with the square root of 2, so it stays there. Hopefully this is old stuff to you as we plug along here. Example number 2, we've got 48 x to the 4th y cubed. That doesn't look very cubey. And we have the square root there. Okay, so let's go ahead and see what we can do. Square root of 48 is also, let's see, are there two numbers multiplied together that give me 48 where I can take the square root of one of those? I've got 8 and 6. I've got 16 and 3. Okay, so that can be written as the square root of 16 times the square root of 3. I can take the square root of 16 and get 4. So notice what I did. I just looked at the number and reduced it. So let's go ahead and put 4 square root of 3. Put the 4 out here and a 3. Okay, so I need to see, let me make a little bit of change here. I'm going to put that 4 out here a little bit. All right, so I reduced that. Now let's look at the x to the 4th and the y cubed. I'm going to put my index of a 2 up here just to remind me. What I do with this is I divide, and this is kind of my own rule to do this, I divide 2 into each of these exponents here. So 2 goes into 4 twice, and there's no remainder. So because 2 goes into x to the 4th twice, I put x squared outside. It pulls out of the radical sign. So 2 goes into 4 twice, so I bring the x out and I put the 2 on there. 2 goes into 3 once, so I pulled that out with the 1. The problem is I have a remainder. What is the remainder? I have a remainder of 1. So one of those y's has to stay in there. So really what we're doing is if the index is 2, I'm pulling all of the pairs out. So there's 2 pairs of x's. So I brought them out, and when I bring them out of the radical sign, I just have 2 pair. And I have 1 pair of y's. So I brought the 1 pair out, but I have 1 left over, 1 single y left over. So that's why I say 2 goes into 4 twice. 2 goes into 3 once with 1 left over, and that is my simplified version here. Okay, so let's try another example here. And let's use the example 3. Let's use one with a cubed root. So I have 40, a to the 5th, b to the 4th. Okay, so what I'm looking for are 2 numbers multiplied together that give me 40, where one of them I can take the cubed root of. So a number times itself. And I'll just give that one to you. At this point, it's 8. So it's 8 times 5. The cubed root of 8 times 5. So the cubed root of 8 is 2. And I can't do anything with the 5, so it's going to stay in here because it's left over. So are you seeing what happens here? I'm trying to find 2 numbers multiplied together, give me 40, where I can take the cubed root of one of them. And the cubed root of that 8 is 2. 2 times 2 is 4 times 2 is 8. Okay, so that's that part of it. That's the number part. Sometimes that's the harder part. Now what I've got is I've got a 3 and an a to the 5th. How many times does 3 go into 5? It goes in there once with 2 left over. Okay, so again, index, how many 3's are in 5? There's 1 and there's 2 left over. The remainders always stay under the radical. 3 goes into 4 one time. with how many left over? 3 goes into 4 once with 1 left over. And again, I just put that 1 on these just to kind of show you that, but they do not have to be on here at all. And that ends up being our simplified form of that. Okay, so continue on with example number 4. Square root of 12 over 6. So what are two numbers multiplied together that give me 12 that I can take the square root of 1? So 4, square root of 4 is 2. Can't do anything with the square root of 3, so that stays under the radical. And then we've got that. Now we've got 2 over 6. 2 over 6 reduces to 1/3. So that equals the square root of 3 over 3 when we're done. Look at another one. So I'm going to automatically change this to 1/3. 5 over 15 is 1/3. So now we have square root of 18 over 3. Two numbers multiplied together give me 18 that I can take the square root of 1. Take the square root of 9 is 3, left with the square root of 2. Those cancel, and we're left with just the square root of 2. I realize I'm going kind of fast, but some of you, this may be old enough that you remember, and you can always watch this again if it's a little confusing what's going on here. Okay, square root of 8, that's the only radical we have there. So we've got square root of 8. Two numbers multiplied together give me 8, 4, and 2, and that's over 2. Square root of 4 is 2. So we just pulled the 2 out, and we can't do anything with that. Okay, so once we get to this point, there's really not a whole lot going on, except I can factor a 2 out of that. So I get 2, 3 plus square root of 2 all over 2. Okay, notice what happened here. I factored out the 2 right here. Okay, it left with a 1. But you can't do anything with this. You treat the exponent or the radical here like a variable. So I factored a 2 out of there, and I got that, and I got that. But you didn't do anything with the x. It stayed. And it's the same way with the radical sign. So treat it like a variable, and then we can cancel my 2's out there. All right, leaving us with a D on example 4. Square root of 45. So that gives me -1 plus 3 square root of 5. Can't do anything with the square root of 5 over 2. And that is all you can do. There is nothing. We can't factor anything out. We can't cancel anything, so that ends up being our simplest problem. Okay, so let's end this video and go into rationalizing the denominator in the next video.